Right.
The only station playing.
Alright, I made these with the yellow or the orange cores. I have a whole box of them. But I ordered these. I didn't know what I was getting. I ordered these on eBay. They got the orange, the green, but they've also got the detector ones. And I didn't even know that that was coming with it. Like the pink and the blue? That's a detector. That's the detector they used to use. But I'm wondering if I use these instead, I'll get better output. That way I won't have to use so much amplification to amplify the audio in the AFC, which is what I've got going on down here. But I've got lots of gain capacitors, so that should be cool. And this looks pretty good. I already tried to drive a transistor off of it. You can drive a transistor off of it, which is a good sign, like directly off of it. So, because before you didn't have a lot of amps or amplification, so I was unable to do that because I was just using these yellow, well, whatever I could find. But I got these. Hopefully it'll turn out a little easier. I'm probably going to make a schematic for this since it basically works, and it works well without distortion. And then I'm probably going to move on to this and try to get these to work, which should be a little easier because I won't have to use like resistors to resist these down because I got too much amplification in them. I was thinking about what you said about your oscillator not functioning properly, but you don't want to plug this probe directly into it because it'll ring, and because it'll act like an inductor. So what you want to do is take the top off of it and just stick it through here, or plug it into a terminal beside it more optimally. But I don't have a terminal beside it because it's got a capacitor in it. It'll stay there. And then from there you can, if you got a spectral analysis on your oscilloscope, you can see where it's at. If there was something actually wrong with it, there'd be like a double peak on here. You see like 2 peaks instead of 1, and they'd follow each other, or they'd be in bursts to each other or something weird like that. Also, there's another thing. You probably won't have to deal with this, but if you're using my schematic, then from a long time ago, it'll be from the base here where the coil connects. And there's a question. Every oscillator is just an amplifier fed back into itself. So if I just have this one coil here, and a lot of them have 2 coils, and I'll explain to you why. If I've just got this connected here or here, both of these can be used as inputs. Like if I put a resistor on here, like a 10K or a 47K more optimally, to positive, and this being an NPN, and then put a capacitor on here. Well, this is going to be the input because this is going to float this base here. But don't worry about that. There's both an input and an output. So I'm going to go from base to collector because that's more easily understood. So if I have this let's say that I have this as the input coil on the base. Where is the output coil, the feedback coil, if I don't have another coil? Well, the secret is this leg. It's acting as an antenna, and it may be possible to shorten it enough where it won't oscillate at 100 megahertz. I've never had it happen, but it could happen. But if you start going lower, you're going to need to add like a loop on the end of here, like 1 turn after a while, because it'll start to not pick up this other side of the coil, and then it'll stop. It won't oscillate basically. And a lot of times when you got these one coils, they got like a PF capacitor that goes across here that helps it oscillate, because that capacitor acts as an input to cause the reverse feedback that causes the oscillation to occur. Okay, I don't know if you can see this or not, but every once in a while I got like a capacitor, and then it loops up, and that goes to a capacitor to one side of the power, and the other side like positive and negative, and that gives me like a fake shield. And then I got another one here, and then I got another one here, and another one here, etc., etc. And the reason for that is when I board this, if I were to board it, what would happen is this IF would drop, and there's something called regenerative IF, and it'll cause distortion in the weak signals and stuff like that. But after I board this, the noise level will drop, but those stations will come in clear after that. But then I gotta amp it back up. You see there's a resistor here that's connected between these two, and that's what's bringing it down a little bit so that it doesn't feed back on itself. When you do this, I had to build this like 3 times to get it right. I originally had it on the side, but this capacitor, but it didn't work properly that way. You want to this coil, it's going to have more turns on it after I deboard this because there's less capacitance on the board, and I'm going to show you that in a minute. And so is this one. This is just something I had in my junk box that apparently worked, and I didn't have to bend the coil all around. But this is, I think it's got like 4 turns on it. It'll have like 6 or something like that after I'm done, or 5. This will have about 6. I know that from experience, after the capacitance is dropped off of it. That's why there's, after I solder or I etch a board with my CNC machine, it's gonna have bodges on the bottom of it probably, because I gotta, debugging these things is a big, the basic component things can be a big pain. Show you how bad this is. If we go to 1 terminal or 2 terminals, you can measure the capacitance off of it. We got over 3 PF just on that. You want to use one of these boards without a metal bottom on it. This one has a metal bottom on it, unfortunately. You can get down to like 2 point something without a metal bottom. But that metal bottom, you think of RF, think of like a mirror and a flashlight, and that metal bottom is going to act like a mirror, and it's going to cause all kinds of trouble. But if we go between here, it's even worse. So it's almost 30 PF. That's because this works the same way a gang capacitor would work, each of these slots. That's why you kind of want to try to eliminate a lot of your signal pass through, and that's why I'm taking, I'll take like a wire and string it down here, and then I'll put a capacitor there. That's how I'm getting FM to work on here. You're only going to get so far on here. Don't expect to get like 400 megahertz off an oscillator on this. You're just going to have to wing it. As far as soldering it together after that, it gets a lot harder, because that's a lot of capacitance between there. Also, I got some 400 kilohertz or 455 kilohertz transformers. It also came with the oscillator transformer. If you wanted shortwave, I'm deciding on how I'm going to deal with that. I got a bunch of gang capacitors. These are 300 PF on the 299 PF from what I'm measuring at the mid-range.